Hello everyone, this is Ian from We Learn to Share, and today we are going to learn about Chapter 1 from PreCalculus. It is functions and their graphs. For the contents, we have lines in the plane, functions, graphs of functions, shifting, reflecting, and stretching graphs, combinations of functions, and lastly, inverse functions. Today we are going to learn about lines in the plane. Before we go in deeper, let's learn about the parent function of a linear function. A parent linear function is fx equals to x. This is the graph of the function, and this parent function has a domain of negative infinity towards to infinity and a range of negative infinity to infinity. Also, its intercept is 0.0. Now we will learn about the slope of linear functions. Slope is change in x over change in y over change in x. This is point y2 minus y1 over x2 minus x1. So how do we find the slope of a line? Let's look at one example question. This graph has 2 points of negative 2, 0 and 3, 1. To find the slope of this function, we can apply what we learned here. So we can put 1, which is y2, and then y1, which is 0, and for the denominator, we can put 3, which is x2, and minus the negative 2, which is x1. There it becomes 1 over 3 plus 2, which equals to 1 over 5, which is the slope that we are looking for. Let's look at another question. Let's take a look at the second example. This graph has 2 points of negative 1, 2 and 2, 2. So here for the numerator, we can put y2 subtracted to y1, so 2 minus 2. And for the denominator, we have to put x2 subtracted by x1, so we can put 2 subtract negative 1, which equals to 0 over 3, which equals to 0. Which is the slope of this graph. Here are some generalizations about the slope of a line. Number 1, a line with a positive slope, m, which is bigger than 0, rises from left to the right. A line with a negative slope, m is smaller than 0, falls from the left to the right. A line with a 0 slope, m equals to 0, is a horizontal line. Lastly, a line with an undefined slope is a vertical line. Now let's look at equations of lines. There are 3 types of equations we can use for writing the linear functions. The first one is general form, the second one is point-slope form, and the last is slope-intercept form. A general form is written as ax plus by plus c equals to 0. This is a general form. However, in this equation, the slope or the points are undefined. Therefore, we use 2 other functions to find the slope or the points. Now let's talk about the point-slope form, which is an equation of the line that passes through the point x1, y1 and has a slope of m. This is how we write the point-slope form. Y minus y1 equals to m multiplied by x minus x1. Then when do we use the point-slope form? This form is used when we find an equation of a non-vertical line passing through 2 points. Let's look at an example. This example is asking us to find an equation of the line that passes through the point 1, -2 and has a slope of 3. This kind of question is when we can use the point slope form to figure out the equation. This is the base that we are going to use, and we can apply it to the numbers here. Y subtracted by -1, which is y1, so we put it here, equals to 3, which is the slope, so m, so we put it here, and x multiplied by x minus 1, which is x1 right here, so we put it right here. And when we simplify this, it becomes y equals to 3x minus 5, which is the point slope form that we found. And here we can find the slope right away, and this becomes the y-intercept of the graph. The point slope form is also called a two-point form. Now let's move on to the slope-intercept form. The slope-intercept form is y equals to mx plus b, and this form is suited for graphing linear equations. Let's look at example number 1. Determine the slope and y-intercept of each linear equation, x plus y equals to 2. First, let's change this into a slope-intercept form right here. Y equals to minus x plus 2, because I put the x right here. So here we can identify that the slope is 1 and the y-intercept is 0, 2. When we graph this, first we graph a y equal to negative x, which is right here, and then we move it upwards by 2, which becomes this graph. And we can easily identify that the y-intercept is 2 and the slope is -1. So here we learned all the 3 forms of lines. Now let's look at parallel and perpendicular. The concept of parallel lines is when 2 distinct lines are parallel, and we can identify this by seeing if their slopes are equal. So m1 is equal to m2. Let's look at one example question. Find the slope-intercept form of the equation of the line that passes through the point -2, 0 and is parallel to the line 2x minus 3y equals to 5. Since this question tells us that the slope is equal to this equation, first let's find the slope of this equation, and then we can apply these points to find the actual form. So when we change this form, it becomes y equals to 2 over 3x minus 5 over 3. Therefore, we can see that the given line has a slope of 2 over 3. Now let's put this in a point slope form. So here, since the point slope form is y minus y1 equals to m multiplied by x minus x1, we can use the points that this question told us. So we put 1 as a y1 right here, and we put this is a subtract, and we put a 2 for x1 right from here, and then we put 2 over 3, which is the slope that we just found. Now if we simplify, the answer becomes y equals to 2 over 3x minus 7 over 3, which is the answer of the problem. Now let's look at perpendicular. When 2 lines are perpendicular, they have slopes of negative reciprocals. So basically, m1 equals to negative m1 over m2. Let's look at one example question. Find the slope intercept form of the equation of the line that passes through the point -2 comma 1 and is perpendicular to the line 2x minus 3y equals to 5. In order to solve this problem, first we have to do the same step that we did in the previous question by finding the slope of this given form. If I simplify this, it becomes y equals to 2 over 3x minus 5 over 3. Therefore, we can see that the slope is 2 over 3. Therefore, the slope of the line must be negative 3 over 2, which is a negative reciprocal of 2 over 3, and passes the points of 2, minus 1. So we can put the identified slope right here in the point slope form. And we can put the given 2 points here. And if we simplify, it becomes y equals to negative 3 over 2x plus 2, which is the answer for this question.